think so.
Perfect. Well, then give them a hand and good luck, guys.
Thank you so much.
Thank you for the lovely invitation. It's personally a big honor to be on this stage. I heard so much good things about this conference. So finally being able to not just participate in this conference, but actually standing on the stage, it's just a huge milestone for me personally. So today, Raresh and I will... Wait, where's Raresh? Where'd he go? Okay, I hope he'll come back soon. So I'm going to have to start without him. The talk today is called Don't Let Compilations Set the Length of Your Coffee Break. So first we're going to start with a small demo that I prepared for you. And let me just quickly build the application so that I can show you. Since everyone is building compilers these days, I decided to give it a go myself. So I created this coffee bundler that is using some sophisticated hashing mechanisms. Well, first of all, it takes the current timestamp and then calculates what is the prime number based on this timestamp. And then it will take this number and feed it to ChatGPT, asking for the nth word in a book, War and Peace. And finally, when we have this word, we can take this for hashing. And since compiling application is very important for every developer, and it's a special moment when you finally have your application running, we decided that it would be shame to let this moment waste. So we are using Midjourney to generate a special memento image for you based on input. So you can always look at this image and come back and remember this amazing time when you built this application. Okay, so just a bit longer. It should be done soon. Don't worry, this was not built with Rust. It's just plain TypeScript.
Sorry.
Oh, here he is.
Is it okay? Oh, cool. Sorry for being late. I knew you were going to build something, so I just
Oh,
some coffee.
perfect.
Yeah.
So consider it. Thank you.
Can I have some coffee?
Yeah. Oh, perfect. Lungo. We need one.
Yeah, my favorite.
Okay, just a bit more. Okay, it's done. Cool.
Nice.
So I know that some of you might have the situations where your builds are just taking ages, and you might be thinking, what makes us procrastinate? And these might be some of the folks or websites you blame. Depending on your preferences, you might lose endless amount of time on one of these websites. But it's not actually the websites that are to be fault for your procrastination. It's the idle time that usually happens during the compilations, when you have some processes that suddenly kick you out of this zone or out of your focus, and then you have to wait for something in seconds or minutes or even hours to finish, and then your focus slowly tunes away, and you start opening websites or start doing some random stuff on the site. And usually, what we do is, in these cases, we blame the tools. It's Webpack that's slow, or Jest, or Cypress, or whatever tool you are using. But to be honest, these tools are quite fast today. It's usually our architecture to be blamed. It's the way we built our software that's making things slow. It's not the tools. Tools are becoming faster and faster, and regardless of how fast we make them, we still manage to fill all the CPUs and spend all the memory and crash our systems. So today, we're going to show you a couple of tricks, how you can battle this, how you can change your architecture, how you can use tools, especially NX, to scale up your architectures so that you don't have to wait so much time when you have to do something. Before that, let us just briefly introduce ourselves. I'm Miro. I come from Vienna.
And hi, everyone. I'm Raresh. I live in Scotland right now. And yeah, today, as Miro just mentioned, we are going to talk about smart build tools and how they can help you, how you can use them to help speed up your tasks. So let's start by thinking how we'd build a specialty coffee delivery app. So we're going to start out with a single Angular app, right? It's going to be a single bundle, like a single folder. And I'm going to put everything in there. But then we can think about extracting these screens out. So we might have a screen for selecting the coffee origin, a screen for customizing the grind size, And finally, a screen for payment, right? Because we want to take that. So, and then our coffee app, you can think of it as just being this very, very thin shell that just routes between all these different screens where we're actually going to hold the business logic and we're actually going to work on. And then we can think a bit more generically. So we might extract some generic coffee components, right? We might start building a design system, maybe a service for making payments. We slowly start thinking in terms of reusable logical building blocks that could potentially be deployed to NPM even independently if we wanted to, but we don't have to, right? These can be local. And we can go even more generic. We might have some utilities for making HTTP calls, some utilities for interacting with Stripe. And you can think of all of these modules that we just created as folders that we've created outside of our initial Angular app. And these folders will start depending on one another. These modules will depend on one another, same as you kind of have a dependency tree forming in your Node modules. But because we're now thinking, and so it's nice to have this, right? Because encapsulation, structure always helps. But because we're now thinking in terms of separate folders, we might be able to create separate just configs in each one of these folders. And if we're just working on our HTTP utilities, instead of having a single just process just run through all of our tests each time, anytime we even push the CI, we can just run a single process just to test our HTTP utilities that we're changing. We can do the same for building. We can add a tsconfig in there, and we can start compiling all of these libraries separately. And we can just build that to Node modules, so it can be reused for other libraries above it. So we can run all these separate tests now. Rather than linting our whole code tree, we can lint individual libraries, and we can build them individually. And we might even have some end-to-end tests, right, that test the outputs of our coffee app. But we'll come back to that later. But now if you're just working on the grind size screen, well, we're first going to need to build our generic coffee components, right? Because they make use of that. We use our coffee components on the grind size screen. But because we build them once, anytime we make changes to our grind size screen, we can reuse that same build of the coffee components that we did the first time without having to rerun them through the Webpack TypeScript loaders each time and having to recompile them. If we switch branches to work on the coffee origin screen, we still have the outputs of the coffee components that we still haven't changed. We still have it on disk, and we can keep reusing that while working on the coffee origin screen.
Okay, yeah, but this sounds interesting, but you are forgetting one important thing. This is actually full of magic that only you as a developer might know. I mean, how do I know how these things are connected? How do I know which project depends on which project? What if we have a new colleague joining team? They have no idea in which order they need to run things. Or what if we want to run it on CI? How do we tell CI, okay, what is the direction? What is the chain of commands in which we have to run? If we, for example, want to build payment screen, based on this graph, we can clearly say that we need to first build payment screen, but before that we need to do util stripe. So the correct order would be util stripe, payment service, and finally our payment screen. But how do we know this? How do we know how these things are connected? If you look at the code, you might see something like this. So our payment screen imports something from our payment service. And this tells us that there's a dependency. Similarly, in payment service, there's another import coming from util stripe, and this tells us that these packages are connected, these folders are connected. So it's all already there, we just have to use it. And this is where monorepos come into help. Because now, in contrast to monoliths or just splitting two folders, if you consider all of these folders as being projects, you can then clearly look at them as isolated parts, and you can see the clear connections between them which are made out of these imports. So when you have something like Annex, based on these imports, you can automatically generate this graph. And each of these edges between the nodes can actually tell you what are those files that make this connection. What are those files that make import, for example, from order admin to coffee origin screen. So if we need to run things on our CI, we know that if we make a change in util stripe, the correct invocation would be that payment service might be affected. So if we change something in util stripe, based on the graph, we can say, okay, there might be something affected in the payments, right? So we better build that one as well. And if we change or build payment service, it might have changed, so we can see that payment screen might have been affected, and by that also our coffee app might be affected. And if our coffee app is affected, we better run those end-to-end tests to make sure we didn't break anything. So you can see that just one small change made a whole chain of affected projects. Now imagine if you randomly make a change without some monorepos, you have no idea what things are affected and what should be built. With monorepos, we can tell you exactly which projects might have been affected. So if we now run our command, if we run the build, you can see that they are actually building in the correct order, as we would expect them, and they're waiting one after another. You can also, probably it's too small for folks in the back, but you can see that first 4 of them have a bit more text next to it. That means that they're referencing the packages that our application depends on, but they haven't been affected, so we just take them from cache, which we're going to talk about later. So this is all cool. We can do this on our local machine, but what about CI? How do we know on CI what to compare with? Locally, we can run git diff, and we can see what files have been changed. We know where these files belong to, and this tells us what projects were changed. But once we make a commit and we push it to GitHub, we no longer have this git diff because our top commit is the same as the commit we just pushed. So if we were, for example, working on branch, we could say, well, we should probably compare it with the previous commit, right? But if we're working on a PR, we don't want to compare it to the previous commit because we'll be skipping all these other commits. We want to compare it to the branching point, right? But if we are pushing to main branch, we can just compare it with the last commit, right? It's simple, or maybe not so simple. What if that last commit has been broken? We don't want to compare against the last commit because we will be swallowing some errors. Also, some previous runs might be pending, so we don't have results for them. So we want to find the last successful build. And this becomes way more complicated very fast. But luckily, NX provides tools for this that will analyze your repository, and it will look at the previous runs, and it would find the last successful run, and it would return the unique hash against which you have to compare to get the proper results.
If you're watching a football game, maybe it's the final of the Euro Cup, and somebody scores a goal, and then it would be weird if in the replay, they would suddenly miss the shot, right? That would be weird. I promise I'm going somewhere with this analogy, but the point is we're used to watching things, seeing events happen, recording them, and then replaying that recording of the events exactly as it happened. So if you imagine our builds, let's say we're building our coffee app. Well, it might take a while, right? Webpack will start up. It's going to start pulling in different files. TypeScript will start compiling things, but eventually it finishes. And we're going to end up with some generated JavaScript bundles in our this folder and some terminal output that describes what happened during our task. Those are the only 2 outputs of our task. So then if I run the same build command a few hours later against the exact same source code without me changing the source code, well, I expect the exact same terminal output and the exact same JavaScript bundles. So what's the point of doing all of that work all over again if it's just going to generate the same things? So this is what a distributed caching mechanism does. It's a central service that listens for what tasks are being run across your whole organization, and it makes sure that no work is ever done twice. So it does this by looking at what tasks everybody's running, like all of your developers, even your CI, and it's aware of the task, and it has an algorithm. So if somebody's trying to run a task that will return the exact same results as the previous task that somebody ran in the past, it's just going to send everyone the previously recorded results. without asking them to redo the work all over again. So let's look at some examples. Your CI is constantly running on all commits that go into your main branch. It's doing build, test, linting, just to ensure that your main branch is in a good state. So when I come into work in the morning and I just pull latest and I want to build my coffee app, I can just instantly replay the results of the build that just happened on CI a few hours ago without me having to wait for it again. That's what the distributed cache does. Let's look at a different example. What if I'm pair programming? I'm pair programming with Miro. I'm making some changes on there. It's all exciting. And when I want to serve the app, it takes a while for me to serve it, right? Because it has to start up and build all of my changes. But then, when it completes, Miro can just instantly serve those changes on his machine because we're working off of the same branch and off of the same source code. And imagine a more advanced scenario. If I open up a pull request to just add a new recipes page to my app, well, CI will start up and it's going to start to validate all of my changes. So let's say it results in this affected graph. So CI will just start linting all of those different libraries to check if my new changes pass linting. And slowly, they're going to start to complete. But I get an error on that library. Linting fails. So then I open up a new commit to fix that error on that specific library that failed. It turns out it was just a forgotten let in there that had to be a const. It failed my whole PR. So normally, we're used, whenever this happens, like maybe a test fails, you have to fix the test, and then you have to wait for, on your second commit, for all of your tasks to run all over again. But in this case, when it comes to linting, we know that that small change that we made in there could not have really affected the lint results of those libraries out there. We know that intuitively, and the caching algorithms know that as well because they're task aware. So then on that second commit, we can just instantly pull the results from the first commit where we did the work. We don't have to rerun it. And we just have to wait to see if only the changes that we actually made on that second commit pass linting again. And after a while, it passes. The most important thing I want to say is, hold on a second. Yeah.
Paresh, what are you doing? Hey.
Hi, yeah, no problem. Yeah, I can talk now.
What are you?
Yeah,
Come on,
sure.
We're on stage, man.
Yeah, no, I can help. Yeah.
What?
Sorry, 2 seconds. Sorry. Mira, really sorry. It was my niece. She's really stressed out. She's doing her math homework.
Oh, again? What?
Do you think we can help her solve her math problem?
Yeah, okay, let's do it.
Yeah,
quickly.
I know it's so yeah. Oh, she's sending her over. So she's sending. Oh, we got the first one in.
Okay, yeah, that's 101, right?
Yeah, perfect.
Okay.
Cool. I'll just let her know.
Anything else?
Yeah, that one. Can you help her with that?
That's 218, right?
Nice. Cool. Okay, we're doing well. What about this one?
Okay, how many of these, man?
Wait, let me check. Sorry, we have quite a few.
No, we don't have time for this. Tell her that we're gonna come back after the talk.
No, we need to do it now. We might need your help. Wait a second. Do you think we can ask? Yeah, maybe you can get some help, right? Like more brains, yeah?
You know math, right?
Cool, let me check. Cool, yeah, okay, so we have them here. Could I ask, right? So this is a game that I built in like a few hours just for this talk, so it might work, it might not. We'll see. If not, I have a backup plan. Could I ask everyone, could you either please scan that QR code or go to that address up there? And we're all going to solve some math problems together. We're going to see how quickly we can solve them if we just kind of distribute the work a bit. So let's see. Just put in a nickname. Can you raise your hand if you have a nickname, if you're in the game? Awesome, yeah. The more people that help, the faster we can help my niece. So, yeah, and the faster you can. So, okay, is everybody ready? Let's see if this will work. Can you see your phone change?
Okay, yeah.
Oh, it's working. Oh, we're going through them.
Wow, you are smart.
Oh, this is so much faster.
Wow, look at that.
Oh my God. Okay, let's.
You should have asked them immediately, not me.
Oh, we're getting some top scorers. Oh my God. Getting a race. We're almost there. We're almost there. We're almost there. Almost there. 2 more. 3 more. 1 more. What's the last one? Ah, okay. I think we're done. We're done. Game ended. Thank you so much. We just did 100 math problems in less than 30 seconds. Or a minute.
Congratulate Sven.
Who is Sven?
Sven.
Nice.
Come see us after the talk. We have a small gift for you.
We have a coffee cup. So you can. Cool. Awesome. So let's see if we can go back to the slides. Okay. 2 seconds. Okay. So distribution works, right? Even with Miro's impressive math skills, there's still so much that a single brain can do. The only way to scale a lot of problems is to start distributing them. So let's look at what happens when you submit a PR. Like, how can we distribute our tasks? Well, when you submit a PR, if you're using a CI system like GitHub Actions, usually it's going to create what are called these VMs, right? So it's going to create these virtual machines that can run computation, they can do computation, they can run processes. And you can customize what happens on them, right? So normally, you might put all of your tasks just to run sequentially on one of these single agents. But that can get slow really quickly, right? As your workspace grows, that can slow down a lot. You might take advantage of the multiple cores of the machine, and you might squeeze them a bit, but you're still going to add new tasks eventually, and you're going to be back in the same place where you have to wait an hour for your CI to finish. We need a strategy for handling distribution of those tasks across more or less VMs. We need to be able to scale somehow. So given this workspace, what are some possible distribution strategies? Well, we can run all of our builds on one agent and all of our lint tasks on an agent. That's going to speed it up a bit, right? Because it's only going to be as slow as our builds now. But look at that. Our builds take a long time. So that one agent will idle away when it could actually be helping that first agent solve the builds faster. OK, so you might say, let's just put half the builds on the second agent, since linting is so quick. But then we have a different problem. Because our end-to-end tests depend on the build of our app so that they can serve the app and test it. And the build of our app depends on the builds of those libraries, which depend on the build of those sub-libraries. So we have this complex dependency graph between our tasks. So in that case, we actually need to run all of those tasks on the same agent so that they have access to each other's outputs on that agent's file system. We already saw how a shared remote caching service can help you avoid unnecessary computation. What if we use that same service to handle distribution of tasks across agents for us? So that's why there's NX Cloud that connects your NX workspaces offers something like this. So you can have your agents, instead of manually defining what each one of them does, you can have them listen for tasks from a central distribution service. So this one agent might get some lint tasks and maybe a build. This other one might get some build and maybe some tests. This third agent might get some tests and some lint tasks to run. And then when the time comes, we can run those end-to-end tests. NX knows from historical runs how long on average each one of your tasks take, so it can distribute them optimally among all the agents you make available to it. And have a look at this. This one agent is just running some tests and some lint tasks. But these end-to-end tests need the build output of an app so that they can serve it. The build that actually happened on this other machine over there. Well, with distributed caching, we saw how it gives us the power to instantly replay tasks across machines. So that means we can actually use distributed caching to quickly move computation across machines. So we can instantly replay the build that's needed on this third agent here, even though it happened on a completely different machine. So now we don't care about how tasks depend on one another when thinking about how to distribute them. And now we have this dial, where if our CI gets too slow, We can just dial it up and just add more agents, and everything will be rebalanced for us. If it gets too expensive, we can dial it down, reduce the number of agents, but at least we're paying a bit less since we maybe improved the speed of our processes. Again, the more granular your graph of tasks is, and the more broken apart they are, like separating the serving of our end-to-end tests to the build of our app, the better decisions a distributed task orchestrator can make.
So you might be thinking to yourself, okay, but come on, how slow can it be, right? I'm going to share with you one sad story about waiting with this fitting Pablo. I was on this kids party, and one of my friends who is working at the biggest international organization, which I would not mention by name, said that they found their process to be very slow and they would like to try Annex and to see if this can improve things. And he was wondering how much they can improve stuff. So I asked him, okay, how long does your build take? And first he couldn't answer. He was like, well, I'm not sure. I was like, okay, what is it? Like seconds, minutes, hours? Like, well, I think it's half an hour. I was like, no, not your full CI, just your build. Yeah, just the build. I was like, so how do you code? Like, whenever you make change, you have to wait half an hour? Oh, no, we run the build just at the end of the day after work, so that when we come early in the morning, we have everything pre-built, and if we kind of forget, then we just build it in the morning while we have morning meetings and rituals. This was scary, but it actually happens quite often. We had a client that had nightly end-to-end tests that at some point became to be longer than 24 hours, so they could no longer be nightly, they had to be bi-nightly. But I don't know, maybe you don't care about speed, maybe you're okay with waiting, but maybe you then care about environment, and using monorepos is good for environment because you save all that CPU, all that electric energy. I have a friend here who wanted to send you one message. So let's recap. Today you heard that in order to speed up things, you should split your apps so that you can tackle problems granularly. You should use affected so that you know what exactly might have been affected and only run processes on those chunks of your code. You should share the cache so that your colleagues in your CI can take the full benefits, and that way you save not only time but also money. And you should distribute work across multiple agents whenever you need an extra push. But don't worry, we don't want to cut down on your coffee breaks. We love our coffees. As a matter of fact, the Annex team loves coffee so much that they decided to give us a book about how to make the perfect coffee at home for our Christmas. So we don't want your coffee break to be shorter. We just think that you deserve to decide on your own when the coffee break should happen and how long it should take. Thank you for listening.